Subscribe and press the bell icon to never miss a video from my school page.
10th CBSE Chemistry Chapter Periodic Classification of Elements. In this video, you will learn the Mendeleevs periodic table, the merits and the limitations of the same. There were many scientists who tried to classify the elements. We have already seen the classification done by Dobereiner and also the Newlands. But the most successful among all these scientists was Mendeleev. Mendeleev was a Russian scientist who was the first to give a periodic table. Mendeleev published his first periodic table in 1869. So when he first published his periodic table, he had known the 63 elements. And he classified the elements based on one of the observations, that is the periodicity of elements. When he started arranging the elements according to the atomic mass, he saw that the elements showed periodic similarity in their chemical properties. And based on this observation, he gave the periodic table. Now, let us study the periodic table given by Mendeleev. Observe here, this is the periodic table given by Mendeleev. Mendeleev's periodic table had 7 rows, which are called as periods, and 8 columns, which are called as groups. 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 columns or groups. And 1, 2, 3, 4, 5, 6, 7. There are 7 rows. So Mendeleev's periodic table had 7 periods and 8 groups. Observe the arrangement of elements in this periodic table. The first element is hydrogen, and see the number here, it's 1.01, which is nothing but the atomic mass of hydrogen. Now see that the row doesn't contain any other elements. Next he moves on to the second row, starts with the lithium, then comes beryllium, boron, carbon, nitrogen, oxygen and fluorine. So in the same way, the arrangement of elements continues. Now observe the number below the symbol of these elements. Here it is 6.94, which is the atomic mass of lithium. Beryllium has 9.01, then boron 10.8 and so on. The observation is that as we move ahead in the periodic table, we see the atomic mass is increasing, right? So this is the basis for the classification of elements by Mendeleev. Mendeleev arranged the elements in an increasing order of their atomic masses. Now there was one more scientist who used the same principle, that is the increasing order of atomic masses. Yes, it was Newlands. Newlands also classified the elements based on atomic masses. When Mendeleev started arranging the elements on an increasing order of atomic number, he observed that the elements in the same group, okay, like for example, if I take group 1, hydrogen, lithium, sodium, potassium and so on. So all these elements had similar chemical properties. Lithium, sodium and potassium do form the Dobereiner's triad. Recall the examples for Dobereiner's triad. Yes, lithium, sodium and potassium did form a Dobereiner's triad, which all had similar chemical properties. All the elements in a particular group had similar chemical properties when arranged in an increasing order of their atomic number. Now, this is a very special observation he made. In the second group, you can see there is one more example of Dobereiner's triads, that is calcium, strontium and barium. Another example you can see here, and there's one more example here. Chlorine, bromine and iodine. Not only the Dobereiner's triads, all the elements in a particular group had the similar chemical properties. This was the observation made by Mendeleev. And based on his observations, he proposed the periodic law. Now let's see what the law states. Mendeleev's periodic law states that the properties of elements are the periodic function of their atomic mass. Yes, we did observe that in his periodic table. The properties of the elements in the same group were similar. This is the basis of the periodic classification of elements. There are more things to learn from the periodic table of Mendeleev. One of the important merits of the periodic table proposed by Mendeleev was that it did predict the existence of unknown elements, like for example, gallium, germanium, and scandium. Now observe these spaces, the boxes which are filled by pink. These are all the boxes which were left blank in the original periodic table proposed by Mendeleev. Mendeleev knew only 63 elements at his time when he designed this table, and while arranging the elements, he did notice that the elements of similar properties came in the same group, and in order to obtain that periodicity, he had to leave some blank spaces in the periodic table. And he very confidently proposed that these blank spaces will be filled by the elements which will be discovered in future. And he did not stop there. He went on and even predicted the chemical properties for those elements. Now, here are those elements: scandium, gallium, germanium, and others. This is the modern periodic table. So these were the spaces here, the ones which are filled with the pink, were left blank by Mendeleev. Mendeleev did give these elements names, like for example, icosilicon, icaboron, and aluminium, where Ica is a Sanskrit word which means that comes after. That comes after. Now let's observe the periodic table. Ica aluminium. So Ica aluminium is the element which comes after aluminium. Ica boron is the element which comes after the boron, and Ica silicon is the element which comes after silicon. So Ica aluminium, the element which comes after aluminium, is now named as gallium. Now in the same case, it's germanium, and germanium is the element Ica silicon, the element which comes after silicon, and Ica boron, scandium, the element which comes after boron. So this was one of the unique properties of Mendeleev's periodic table. Mendeleev's periodic table also had provisions to accommodate the noble gases which were undiscovered at his time. That is the reason here you see that these noble gases are colored in pink. So these were the merits of Mendeleev's periodic table. Though Mendeleev's periodic table was successful in predicting the unknown elements and their properties, it did have limitations. It's now the time to understand the limitations of periodic table given by Mendeleev. The elements tellurium and iodine. Observe the atomic masses of these two elements. Tellurium with the atomic mass of 128 is placed first, and iodine, which has the less atomic mass, 127, is placed after. Now this is not in the increasing order of atomic mass. So this was a mistake made by Mendeleev. In order to get the elements with the similar properties one below the other, Mendeleev placed some elements in the wrong position. Another important drawback of Mendeleev periodic table was that Mendeleev could not give proper position to the isotopes of the elements. Like for example, chlorine. Chlorine has two isotopes: chlorine 35 with the atomic mass 35 and chlorine 37 with the atomic mass 37. Mendeleev could not give proper position to the isotopes of chlorine. What the modern periodic table does is that it takes the average of the two atomic masses of the isotopes and gives that in the periodic table. And the final important limitation of Mendeleev periodic table was that it could not assign a proper position to hydrogen. Hydrogen is a very special element with the properties of both alkali metals that is the elements in the first group, and also the properties of halogens, chlorine, bromine, fluorine, and iodine. So with these two properties, hydrogen was placed in the first group of alkali metals only. So these were some of the limitations of Mendeleev's periodic table. Now let's revise quickly. Mendeleev's periodic law. Mendeleev's periodic law states that the properties of elements are the periodic function of their atomic masses. Merits include: it was able to predict the existence of the elements that were not discovered during the time of Mendel. Mendeleev was also able to predict the properties of some elements based on the position of the elements in the periodic table. Mendeleev's periodic table did allow the accommodation of noble gases. So these were some of the important merits of Mendeleev's periodic table. Now let's move on to the limitation. Mendeleev did leave gaps in the periodic table, and he arranged few elements in the wrong order of atomic masses. We saw the example for that. Mendeleev could not explain the position of isotopes, and also he couldn't give a proper position to the element hydrogen. Though Mendeleev's periodic table had limitation, it is considered as one of the outstanding works in chemistry, and it is after his periodic table was proposed that the modern periodic table came to the existence. So the modern periodic table has its foundation in Mendeleev's periodic table. In this video, you studied Mendeleev's periodic table, its merits, and also the limitations.
Hi, if this video was helpful, please like and share it with your friends and subscribe to my school page for more videos. Also, let us know how we can help you in your studies in the comments section below, and contact us if you're looking for personalized tuitions to get better grades.